Hi everyone, today we are going to learn about how to write equations of ellipses. I'm going to give you information like the vertex, covertex, center, or focus, and then ask you to write an equation based on that information. But before we get started, I have a really quick warm-up for you, and that is, in how many ways can you arrange 5 books on a shelf? This is a very typical problem of something that we would have seen back in our probability unit of chapter 10. But I want to see what you remember. So go ahead and pause the video and answer this question, and then we'll see how well you did. All right, so there are several approaches for this problem. You could have used factorial, 5 factorial, in which that means that out of my 5 books being arranged on a shelf, the key word here was arrangement. You could say that 5 books would be in the first position. Once 1 is in the first position, you have 4 left to go into the second position, then 3 left to go into the third position, then 2 left to go into the fourth position, and only 1 left to go into the fifth position. So when you multiply all of those numbers together, you'll end up with 120 different ways to arrange 5 books on a shelf. That's one approach. Maybe you saw the word arrange and said, oh, I remember permutations. And if I have 5 books and I want to arrange them in 5 different ways, 5p5, if you were to put that into your calculator, is also 120 ways. So both approaches would get you the right answer. If you totally forgot how to do problems like these, then what I strongly recommend that you do is you start looking back into your notes, because we're heading right into our final exam time coming up within the next few weeks. So now let's go ahead and write equations of an ellipse. Now remember that the general format of an ellipse where the center is located at 0, 0 is going to be x squared divided by a squared plus y squared divided by b squared equals 1. And the way to tell if, whenever you're given like a vertex versus a covertex, the vertex is going to be, in this case, 0 is -7. Notice that -7 is in the y position. That means that my big number needs to be below y squared. And my covertex is located in the x position. So what I'm going to do is I'm going to square -7. -7 is going to go below y, and 4 squared is going to go below x. So I'm going to write x squared divided by, and I'm going to take that 4 and square it, plus I'm going to write y squared divided by, I'm going to take that -7 and square that, and that's going to be equal to 1. Simplifying this equation even further, my answer is x squared divided by 16 plus y squared divided by 49 equals 1. And that is my equation. That is all that you do. So what we do here is we're going to look at in what position is the number. In this case, our number was located in the y position, so -7 would go below y. We're going to make sure we square that value. 4 was located in the x position, so I'm going to make sure that 4 squared would go below the x squared in that fraction. And then it's equal to 1. All right, let's go ahead and look at example number 6. We want to write an equation of an ellipse that has a vertex at 7, 0, a covertex at 0, 2, and our center is at 0, 0. So once again, we're going to be using that x squared over a squared plus y squared over b squared equals 1. Notice this time that 7 is located in the x position, so that means that I'm going to have x squared divided by 7 squared plus, notice that 2 is located in the y position, so I'm going to have y squared over 2 squared. This is going to equal 1. Cleaning it up a little bit, my equation is going to be x squared over 49 plus y squared over 4 equals 1, and that's my equation. But number 7 is a little bit different. This time around, I'm telling you that the vertex is located at 0, 10, but the focus is at 0, 8. Our center is at 0, 0. So we're still going to use the same equation, and 10 is our vertex, and it's located in the y position, so we know that it's going to go below y, but I don't know what's going to go below the x squared. That's what I have to figure out. So I know that I'm going to do 10 squared, which is 100, and this is going to equal 1, but I need to know what's going to go into this space. And what I know here is that my focus is at 0, 8. So I'm going to use my formula that c is equal to plus or minus the square root of a squared minus b squared, and in order to help me to figure out what goes below the x squared. Now remember, like I said last time in the video, we're going to use these numbers interchangeably, making sure that the large number goes first. And since 10 is part of our vertex, we know that 100 is going to be the large number. So I'm going to replace c with the number 8. So I'm going to write 8 equals, and instead of using plus or minus, I'm just going to write square root, because 8 is already going to be the positive value. We would anticipate that 0, negative 8 would be the other focus. But I'm just going to write 8 equals 100 minus, and we'll call it b squared. It doesn't really matter what letter you assign it. You can call it b squared, you can call it a squared, whatever floats your boat. Because whatever this number turns out to be is going to go into this position below the x squared. So it doesn't matter what letter you're using. That's not what I need you to focus on. So we have this square root equation that we need to solve, and I'm going to square both sides. And when you do that, you end up with 64 is equal to, the square eliminates the square root, leaving us with 100 minus b squared. I'm going to subtract 100 on both sides, and when I do that, I end up with negative 36 is equal to negative b squared. Well, if I were to flip-flop the sides, I would end up with b squared is equal to positive 36. So taking the square root of both sides, b is equal to 6. So I didn't really need to identify what b was. I just needed to know what b squared was. Now that I'm putting that out there, I just need to know what the squared term is. So I didn't even need to take the square root, because I want to know what the square is. Because remember that this is like a squared plus b squared. And like I said, the a's and the b's don't really matter. It's just a general form. So that means that 36 is going to go below the x squared. And that is our answer. So that's our equation. X squared over 36 plus y squared over 100 is equal to 1. So let's do another problem just like that. So this time around, I'm telling you that the vertex is located at negative 5, 0, and our focus is at 3, 0. So this is a focus again, and our center is at 0, 0, and we want to write an equation. Now, because our vertex is negative 5, 0, negative 5 is located in the x position. So that means that I know what's going to go below x squared. Negative 5 times negative 5 is positive 25. So positive 25 will be below x squared. What I don't know is what's going to go below y squared. And I know this is supposed to equal 1. So I'm going to use my formula for focus, and I'm going to write, use that c is equal to the square root of a squared minus b squared. Like I said, don't worry about the a's and the b's and all of that fun stuff, but what I'm going to do is I know that my c value is going to be 3, so I'm going to write that 3 is equal to the square root. And since our vertex is going to be at negative 5, 0, that tells me that 25 is my biggest square. So I'm going to make this 25 minus b squared. It doesn't matter that this is b squared or a squared. Whatever letter you assign it, you can call it x for all I care. Or call it some other letter, not x, because obviously we're using x in our formula. But you could call it anything. We just want to figure out the number that's going to go below y squared. So we essentially need to solve for b squared. So I'm going to start by squaring both sides, and I end up with 9 is equal to 25 minus b squared. I'm going to subtract 25 on both sides, and when I do that, I end up with negative 16 is equal to negative b squared. And if I were to flip-flop each side by like adding 16 to both sides and adding b squared to both sides, I would end up with b squared is equal to 16. I don't need to take the square root because I don't need to know what b is because I am not graphing these. So this number is going to go below y squared. 16 goes below y squared, and my answer is x squared over 25 plus y squared over 16 equals 1. Now for number 7, what we want to do is this time around I'm giving you a center that is not 0, 0. So since center is not at 0, 0, we're going to be working with the formula of x minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. So that's our formula that we're going to be working with. So we already know what's going to go into our parentheses up here. And I know that that's going to be x, and then the opposite of -2 is +2, so x plus 2 squared over something, I don't know what it's going to be quite yet, plus, I'm going to write y, and then the opposite of +1 is -1, so y minus 1 squared over something, I don't know what it is yet, equals 1. So now, since this is our center, look at our vertex. Our vertex is located at -2, 5. So the thing that changed here is the y value. How it changed is this. To go from 1 to 5, we add 4. So that means that below y, I'm going to square 4. 4 squared is 16. And since it's the change in y, 16 is going to go below y. Let's look at our co-vertex. The thing that changed in these two ordered pairs is our x value. To go from -2 to -5, we're subtracting 3. And so that's going to be -3 squared, and -3 squared is 9. So 9 would go below x, because that's the part that changed. And that's your answer. So the way to analyze this again is to check out which piece of the ordered pair changed compared to the center. So that's what you would do for those types of problems. All right, we have one more problem and then we are finished for today's lesson, and that is talking about how to find the area of an ellipse. And the area of an ellipse is going to be A is equal to pi times A times B. So you remember that your A and your B values come from taking the square root of your denominators. So number 8 says, marketing research allows that a hand lotion bottle with an elliptical base is easier to hold than a similar sized bottle with a circular base. We want to write an equation of the ellipse, and then we want to find the area of the elliptical base. So let's focus on the base first. I'm going to draw a really quick sketch. Notice that this is horizontal. So I'm going to make this the major axes, the horizontal axes. And it's just going to be a really quick sketch. All right. I know that based on this picture, that the full distance straight across, is going to be 8 centimeters. So this is 8 centimeters. So if you were to think about like a coordinate plane, half of each side would be 4 centimeters. And then my distance going vertically is 6 centimeters. So coming over to my little picture over here, I know that from end to end, from vertex to vertex, this is 8 centimeters. So that means that this would have to be 4 centimeters, and this is 4 centimeters. And then vertically, this is supposed to be 6 centimeters. So each piece right here is 3 centimeters and 3 centimeters. So I'm going to say that in my equation, we're going to assume that this is centered at 0, 0. I'm going to be working with x squared divided by, and it's going to be along my horizontal, I'm going to square 4, and that's going to make that 16, plus y squared divided by Along my vertical, that's 3. 3 squared is 9 equals 1. So that's my equation of this ellipse centered at 0, 0. We're just going to assume that's centered at 0, 0 because they didn't give us any other information. And now what we want to do is we want to find the area. Now, our area is going to be equal to pi times A times B. Now, our A value in this case is 4, so A would be equal to 4, and our B value would be equal to 3. So I'm going to write area is equal to pi times 4 times 3. So our area is equal to 12 pi, and our units over here is centimeters, so that's going to be 12 pi centimeters squared. Or if they ask for an approximate answer, rounding to the nearest tenth, like we've done this entire lesson, or this entire unit so far, is going to be 37.7 centimeters squared. So this is your exact, it's in terms of pi, and here's your approximate. That is the end of today's lesson. Hopefully today's lesson was not that bad for you. If you're struggling with it, please feel free to email me as always. But I hope you have a wonderful day.